Hello class, this is Mr. Hart. In this podcast, I want to go over how we work with units in physics because a lot of times the students know how to type the numbers into the calculator and get the answer, but they don't know how to write it down and express it with the proper units. And so I like to spend a full day in class just learning how do we express units in physics properly. Okay, because for example, in a math class, you may have a problem like this where you have x, you have y, and you're trying to find some value of the two. So if you were trying to do that problem, for example, you would say, well, x plus y, or 2y, equals 21.7 times 2 times 3.2. Okay. Sorry, that's a plus. And then you would, get your calculator out. You'd type it in, 21.7 plus 2 times 3.2. And you get that the answer is 28.1. Okay, boom, you're done. That's all you need to do for a math problem. Okay, now you may find similar problems in physics, okay, but now they have some units with them as well. Okay, so you may have the exact same question, except now you have centimeters attached to the unit or attached to the problem. So how would you express your answer? Your number is still going to be the same, but now you need to work with the units. Okay, so that's what we want to focus on, not so much on getting the number, because that's the easy part. That's just typing it in your calculator, you get an answer. We want to learn how to express units with our answers. Okay, so the first thing you want to learn with units is when you're adding quantities, okay, you can't add them unless they have the same units. Okay, it doesn't make any mathematical or physical sense. So for example, this one right here, 72.1 kilograms plus 35,000 grams, doesn't really make a whole lot of sense to add. Okay. So we're just going to cross that one out right now, okay, because we don't really want to use, or we can't really add those two quantities because they're not the same units. Before we can do anything, we have to convert these grams over here into kilograms. Okay, so you remember last time how we did the unit conversion factors? You would convert that grams into kilograms, and then you could get the proper units. Okay, and then you could add these two quantities. You'd have 72.1 kilograms plus 35 grams. You add that out, and you get about 107.1 kilograms. Okay, so that's the first key with units, is you can't add anything if they're not in the same units. That's why we practiced converting units last time, so that we could get them into the right units beforehand. Okay, and another thing with units is you can kind of treat them like variables. Okay, so if you have a meter and a meter, okay, 1 meter plus 1 meter, you can imagine if this was 1x and 1x, you could get 2x over here, so 2 meters. Okay, so it's kind of like a variable in that way. You can treat them the same when you're doing arithmetic. Okay, a meter times a meter, for example, would be a meter squared, just like x times x would be x squared. 1 kilogram times 1 meter gives you 1 kilogram meter. Okay, so when you're doing the arithmetic with units, you can treat them just like you would any other variable. Okay, here's a couple more examples. Meter squared over a meter equals 1 meter, right? Those cancel out, give you 1 meter. And a kilogram times a meter over 2 seconds squared, if you separate it out, you get 1/2, and a kilogram times meters per second squared. Okay, so again, it's not really tricky in any way. It's just trying to learn how to write the units down. Okay, so in this example down here, we could write 1 kilogram times meter over 2 seconds squared. That's perfectly fine. That's a right answer. But usually in physics, when we're expressing our answers, we like to separate it out as the number and the units separately. Okay, so that's another skill with units, is learn to work with the numbers and the units separately. Okay, you don't want to mix them in with each other. I like to separate them out before I do the problem, the numbers on one side and the units on the other side. Okay, and then you always express those units after the number. Okay, so let's just try a couple of examples. I think that's the easiest way to get used to working with units. Okay, so let's say we have a physics problem and it tells us that V is equal to D over T, and we know that D is equal to 5 meters and T is equal to 6 seconds. Okay, well, how would we set this up? We're going to take these 5 meters, plug it into D. We're going to take this 6 seconds, plug in for T, and find out what V is. Okay, so when we do that problem, we get that V equals 5 meters over 6 seconds. And again, we could leave it like this if we wanted to, but usually in physics we like to separate them out, so that would be 5 over 6 times meters over seconds. Okay. And so if you want to write your answer properly, we want you to separate the units out like that. All right, let's do another example. Let's say you have an equation where I is equal to P over 4 pi r squared, and P is equal to 30 watts, and R is equal to 2 meters. Again, we're going to take this P equals 30 watts and plug it in right there, and R is equal to 2 meters and plug it in right there. Okay, so let's see what happens when we do this. Okay, so I'll do this one by hand so you can kind of see what happens. So we have I equals P over 4 pi r squared. Okay, and so we plug in what we had. We had 30 W or 30 watts, okay, for P, and we have 4 pi r squared, and R was 2 meters squared. Okay, so now what we want to do is we want to, again, separate the units from the numbers. Okay, so I'm going to take all the numbers and write them separately. So we had 30, okay, over 4 pi, and that 2 was squared. Okay, that's all the numbers. Now let's look at the units. We had a watts and we had a meter, but that meter was squared, so we got to remember that that meter was squared as well. Okay, so when you're working with these problems, make sure that anytime you square the number, you also square the unit. Okay, you want to keep track of that. That's one of the biggest errors we see in physics, is not remembering to square units when their numbers are squared. Okay, so now it's really easy. You would just type this out in your calculator, get a number, and then you get W over meters squared, or watts over meters squared. Okay, so let's check to make sure we got that right. And so this is how it will look on a paper, for example. So again, you plug everything in, you separate the numbers from the units, and then you get a number in your calculator and the units on the right side. Okay. All right, let's do a couple more examples. Okay, so we have A equals V over T. V is equal to 6 meters per second, and T is equal to 3 seconds. Okay, so if we work with this example, we plug everything in. V was 6 meters per second, T was 3 seconds, and so then we separate the numbers, which gives us 6 over 3, and then the units are meters per second per second. Okay. Now this one's a little tricky because the number's 2, that's really easy to find, but meters per second is a little hard to think about, so we want to rewrite this in a way to make it easier to read. And a lot of students will say, oh, I got a seconds right here and we got a seconds right there, they should cancel out. But that's not the case because it's over another fraction. Okay, so you can imagine that this is a second over 1, for example, and then you could times that up here as 1 over seconds. So now you have meters times 1 and seconds times seconds. That's what's going to give you this second squared over here. Okay, and so be careful not to cancel out seconds when they really should be times together. So if you ever have a complex fraction, a fraction over a fraction, remember to kind of do the reciprocal, flip this upside down and times it to make sure you get the right units on that. Okay, let's do one more example. Let's say that F is equal to M times A, and M is equal to 2 kilograms, and A is equal to 5 meters per second squared. Okay, we're trying to figure out what F is equal. So again, we're going to take the units, and we're just going to plug in everything together. So we got 2 kilograms times 5 meters per second squared. Now we'll separate the numbers, 2 and 5, that's going to give us 10. And the units times together are kilograms times meters per second squared. The last step, though, is in that unit reference sheet that I gave you, there is a box on the left side called derived units, and those derived units sometimes have special names. So for example, kilograms times meter per second squared, if you look, is actually the derived unit of a Newton. Okay? And so that derived unit can be rewritten as an N. If we ever see a kilogram times meter per second squared, we can just write capital N instead. Okay? And so if you ever see any of those derived units from your reference sheet, Okay, go ahead and plug them in and rewrite them so it's easier to read. Okay. Alrighty, so that's all you're doing for your homework. It's just a lot of these types of problems where I give you an equation, some things to plug in, and you just have to write the answer with numbers and the units. Okay, so don't worry so much about the math. It's really simple math. It's just plugging in your calculator. What I want you to focus on is writing the units in the right way for this homework. Okay, but that's all I wanted to cover. Let me know if you have any questions, and thank you for watching.